Hello everyone. So in today's lecture, we will understand about the Bayesian brief network, and this is very useful techniques for solving the problems for solving the uncertain types of knowledge. So after learning this lesson, you will properly understand about the Bayesian brief network and um, what is a Bayesian belief network and how it's work. Okay, so let's start. What is Bayesian brief network in artificial intelligence? So, Bayesian belief network is a key computer technology for dealing with the probabilistic event and to solve a problem which has uncertainty. So we can define a Bayesian network as a Bayesian network is a probabilistic graphical model which represent a set of variable and their conditional dependency using a directed acyclic graph. So it is also called a base network or a belief network, or you can also say that Bayesian model. So the Bayesian network are the probabilistic because these network are built from probability distribution and also use the probability theory for the prediction and anomaly detections. So the real world application are a probabilistic in nature, and to represent the relationship between multiple events, we need a Bayesian network. It can also be used in a various tasking, including prediction, anomaly detection, and diagnosis, and automated insight and reasoning, and also a time series prediction. So Bayesian network can be used for building model for data and expert opinion, and it consists of a two parts. First one is directed cyclic graph, and second one is a uh, table of conditional probabilities. Okay. So the generalized form of Bayesian network that represent and also decision problem under the uncertain knowledge is known as influence diagram. So the Bayesian network graph is made up of node and arc, where each node corresponds to the random variables, and the variable can be continuous or a discrete, and arc or directed arrow represent the causal relationship of conditional probability between the random variables. Okay, so these directed links or arrow connect the pair of node in the graph, and these link represent that the one node directly influence the other node. And if there is a no directed links, that means the node are independent in each other, right? So in this diagram, you can see here in this diagram, a, b, c, and d are a random variable represented by the node of network graph. So if we are considering node b, which is connected with the node A by directed arrows, then a node A is called the parents of node B, and node C is independent of node A. So a Bayesian network has mainly two components. First one is a causal component, and second one is a actual number. So each node in the Bayesian network has a condition probability distribution which determine the effect of the parents on the node. So the Bayesian network is based on the joint probability distribution and conditional probability. So let's first understand what is joint probability distribution. Okay, so if we have a variable that is x1, x2, x3 up to xn, when the probability of a different combination of x1, x2, x3, and xn are known as a joint probability distribution. So probability of x1 comma x2 comma x3 up to xn, it can be written as the following way in term of joint probability distribution. Either probability of x1 slash x2 x2 comma x3 comma up to xn. and the probability of x2 comma x3 comma xn, something like that. Okay, and either it can be written as a probability of x1 by x2 comma x3 up to xn, and probability of x2 by x3 to up to xn, and same like that probability of x of n minus 1 divided by x of n and p of x of n. Okay, so in general, for each variable xi, we can write the equation as p of xi by xi minus 1 up to x1 equal to p of xi divided by parents of xi, right? So let's understand the Bayesian network with the examples. Okay, so Harry installed a new bulgar burglar alarm at his home to detect uh, burglary. Okay, and the alarm reliably respond at detecting the burglary, but also respond for minor earthquake. So Harry has a two neighbor, David and Sophia, who have taken a responsibility to inform Harry at work when they hear the alarm. So David always call Harry when he hear the alarm, but sometime he got confused with the phone ringing and call at the time too. So on the other hand, Sophia like to listen to a high music, so sometimes she misses to hear the alarm. So here we would like to compute the probability of burglary alarm. Okay, so the problem is, firstly we need to calculate the probability calculate the probability that the alarm has sounded, but there is neither a bulgari or nor an earthquake occurred. So and David and Sophia both call the Harry. Okay, so the solution for this is the Bayesian network for this above problem is a given that the network structure is showing. See, you can see here this network structure. The network structure is showing that the burglary and the earthquake is the parent node of the alarm and directly affecting the probability of alarm going off. But David and Sophia calls depend on alarm probability, right? So the network is representing that our assumption do not directly perceive the burglary and also do not notice the minor earthquake, and they also not confer before calling. Okay, so the conditional distribution for each node are given as a conditional probability table, or you can say that CPT. Okay, so each row in the conditional probability table must be sum to 1, because all the entries in the table represent an uh, exhaustive set of cases for the variables. So in the conditional probability table, a boolean variable with a k boolean represent boolean parents contain 2 to the power k probability. So hence, if there are two parents, then CPT will contain four probability value, right? First one, list of all events occurring in this network. First one is a burglary, that is B, E for earthquake, A for alarm, and D for David call, and S for Sophia call. So we can write the events of problem statement in the form of probability, that is probability of D comma S comma A comma B comma E. So it can be written, write the above probability statement using the joint probability distribution, that is probability of D comma S comma A comma B comma E is equal to probability of D by S comma A comma B comma E into probability of S comma A comma B comma E, right? that is equal to probability of D by S comma A comma B comma E into probability of S by A comma B comma E into probability of A comma B comma E, right? Or equal to probability of D, well, the same like that. For each and every variables, okay, we can write the joint probability distribution statement, right? So for that we already wrote that, and you can see in this diagram. Let us take an observe probability for the Burgality and the earthquake component is a P of B equal to true is equal to 0.002, which is the probability of Burgality, and whereas P of B equal to false is equal to 0.998, which is the probability of no Burgality, right? And P of E is equal to true is equal to 0.001, which is the probability of minor earthquake, and P of E equal to false is equal to 0.999, which is the probability that the earthquake not occurred. So we can provide the conditional probability as per the table. So conditional probability table for the alarm A is the conditional probability table for alarm A is the conditional probability of alarm alarm A depend on the Vergaler and earthquake, right? So for example, I am taking here two variables, that is P and E. So for example, I'm taking here only two uh, variables P and E. So definitely four sets we have, four different cases we have. So in which B is also true, E is also true. So in which in that case, P of A equal to true means alarm will be sounded is equal to 0.94, whereas P of A equal to false is 0.06. In the second case, that P is true but E is false, okay, E is false. So in that case, P of A equal to true is 0.95, whereas P of A equal to false is 0.04. So same like that, guys. We will create each and every table for each and every conditional probability table for an alarm, for a David call, or for a Sophia call. And after that, we will put that value in the form of joint probability distribution, and we will find the answer of that. Okay. So this is how Bayesian network actually works. Okay, this is how Bayesian network actually works. Agent can only agent can only perceive the closed environment, which is an adjacent room. Okay. So what is deterministic? It is deterministic as the result and outcome of the world is already known. Okay. What is sequential? The order is important, so it is sequential. Next is static. So it is static as bumpers and pits are not moving. Okay. It is static as bumpers and pits are not moving. Okay. Discrete. The environment is discrete. Next one isn't. The environment is single. The environment is a single agent. As we have one agent, only the wumpus is not considered as an agent. So exploring the wumpus world. Okay. So we will explore the wumpus world, and we will determine how an agent will find its goal by applying a logical reasoning. So agent's first step is initially the agent is in first room, that is 1 square, right? And we already know that this room is safe. This room is safe for agent, right? This room is safe for agent. So the so to represent one the below one this diagram, that room is safe. The room is safe. We will add a symbol. Okay. Okay. So symbol A is used to represent agent. Symbol B is B for Brizzy, and G for glitter or gold, and V for visited room. Okay, and P is for pits, W is for wumpus. So at room 11, agent does not feel any breezy or any stench. So which means that adjacent square are also okay. Okay, so there are two adjacent. We cannot take a diagonal here. Okay, we cannot take diagonal here. So obviously both adjacent are written as a okay. Next, in the second step, now agent need to move forward, so it will either move to 1 2 or 2 1, right? 1 2 or 2 1, because both are okay. So let's suppose agent move to room 2 1. Okay, Azent moved to room 2-1 at this at 2-1. At this room, Agent perceives some breezy. Okay, some breezy, which means Pitts is around. So Pitts is around this room. So Pitts can be in 3-1 or 2-2, right? 3-1 or maybe 2-2, because adjacent of 2-1 is three things: 1-1, 2-2, and 3-1. 1-1 is already visited, right? 1-1 is already visited. 2-2, 3-1, both are they are remaining adjacent. So let's suppose agent move. So let's 2-2 and 3 win symbol. So we will add symbol P. So we will add symbol P in 3-1 and 2-2. Okay, symbol P at P added symbol P at a 2-2 or 3-1. So we say that to say that it in this pit room. Okay, is this a pit room? So now agent will stop and think, and will not make any harmful moves. The agent will go back to the 1-1 room, and the room 1-1 uh, and the room 1-1 and 2-1 are visited by the agent. 2-1 are visited by the agent, so we will use symbol V to represent the visited square. Okay, so guys, let's understand what is third step. Okay, what is third step? So at the third step, now agent will move to the room 1-2. Okay, room 1-2, because as we know that 1-1 is okay, and just adjacent to the 1-1, 2-2, sorry, 2-1 and 1-2 are present. But when first we visit 2-1, and we find the how many adjacent are there. So 2-2 and 3-1 are adjacent, but it find breezy. So definitely definitely it is a pit room. So it just again it's just marks 2-2 and 3-1 as a P, and just return back to again 1-1. Okay, uh, now 1-1, because it again returned back to the 1-1, so 1-1 is marked as a visited, and now it's reached to 1-2. Okay, 1-2, because previous second adjacent is a 1-2, so now 1-2 is also okay, so it just reached to the 1-2. So now agent will move through the room 1-2, which is okay. So in this room, 1-2 agent perceive a strange, which means that there must be a wombs nearby. But wombs cannot be in the room 1-1, as by the rule of game, and also not in 2-2. Okay, also not in 2-2, because agent has not uh, uh, detected any stench where it has at 2-1. Okay, so therefore agent infer that wumpus is in the room 1-3, and it is a current state. Okay, so there is a no bridge, which means in two two there, which means in two two, there is a no pit. Okay, there is a no pit and no wombs. So it is safe. Okay, so it is safe, and we will make it okay, and we will make it okay, and the agent move further in 2 2. Okay. Now for the fourth step, at the room 2 2, there is no strange, right? And no breezy present. So let's suppose agent decide to move to 2 3 at the 2 3 at the room 2 3, and at room 2 3 agent perceive glitter. So it should grab the gold and climb out of the cave. Okay. So, guys, next topic is knowledge base for the Wumpus world. So, as in the previous topic, we have learned about the Wumpus world and how knowledge base agent involve the world. Now, in this topic, we will create a knowledge base for the Wumpus world, and we will derive some proofs for the Wumpus world using a propositional logic. Okay, using a propositional logic. So, a agent starts visit for first square, that is 1 1, and we already know that this room is safe for an agent. But to build a knowledge base for Wumpus world, we will use some rule and atomic properties. So we need a symbol, that is I comma j, for each location in the Wumpus world, and where I is for the location of row, and j for location for column location. Okay. So, what is atomic properties? What is atomic proposition variable of a Wumpus world? Okay. So let's peak ij pij be true if there is a pit in the room, that in the room I comma j. Okay. Let bij be the true if bij be the true if agent perceive breezy in ij. Okay. So either he will dead or alive. Next, let's wij be true if there is a Wumpus in the square, that is I comma j, in a square I comma j. Let I comma j be true if agent perceives the stench in the square I comma j. So let I comma j be true if that square I comma j is visited. So let g ij be true if there is a gold. Okay. And a glitter in present in a square I comma j. And let okay I comma j be true if room is safe. Okay, room is safe. So some propositional rule for the Wumpus world is R1, that is not S11 implies to not W11, conjunction not W12, conjunction not W21. Next for the R2, for R2, not S21 implies to not W11, conjunction not W21, conjunction W22 W21 conjunction, not W22 conjunction, not W31. For R3 row, not S12, not S12 implies, not S12 implies W11, W11, W11 conjunction, not W12 conjunction, not W22 conjunction, not W13. So for R1 row, S12 implies that W13 uh, disjunction, W12 disjunction, W22 disjunction, W11. Okay. So this is some propositional rule for the Wumpus world. Okay. So now understand the representation of knowledge base for the Wumpus world. Okay. So this is a simple the simple knowledge base for Wumpus world, where an agent moves from room 11 to room 21. Okay. And guys, in this diagram you can see that three row and one, two, three, four, five, six, seven column are made, right? Three rows and seven column are made. So here is the first row, and we have mentioned propositional variable for the one. So which is showing that room doesn't have Wumpus, that is not W11. Okay. So obviously no stance, that is no stance, no stench means not S11. No pits means not P11. No breezy, that is not B11. No gold, that is not G11. Visited the V11, and the room is safe. Then the room is safe. So for that, OK11. Okay. So in the second row, we have mentioned propositional variable for the room 1 2. Okay, so which is showing that there is a no womps, there is a no wumpus stench, and breezy are unknown as an agent not visited room 1 2. No pits not visited yet, and not visited yet, and the room is safe. So in the third row, we have mentioned propositional variable of room 21, and which is showing that there is a no wumpus, that is it written that not W21. No stands, that is not S21. No pits, that is not P21. Perceives breezy, so that's why it written as a B21. Okay. No glitter, that's why it written as a not G21. Visited V21. Okay. And room is safe, so okay 21. So to prove that Wumpus is in the room 1 3, we can prove that Wumpus is in room 1 2 using propositional rule. Which we have derived for the Wumpus world, and using inference rule. So apply modus ponens with the not S11 uh, and R1. So we will firstly apply modus ponens rule with the R1, which is not S11 implies to, which is not S11 implies to not W11, uh, and not W12 and not W21, and not S11 will not S11, which will give out which give out the output not W1, not W which give the output not W11, and not W12 and W12. Okay, so guys, see, after applying the modus ponens rule, that is on the not S11 implies to not W11 and not W12 and not W21, then we will get the output not W11 and not W12 and not W21. Okay. Next we apply and elimination rule. Okay, apply and elimination rule. So after applying a elimination rule to not W11 and not W12 and not W21, we will get three statements. Okay, first statement is not W11, second statement is not W12, and third statement is not W21. So after applying modus ponens to not S, after apply modus ponens to not S21 and R2. Okay. So now we will apply modus ponens to not S21. Okay. Before that we apply on a S11. Now we will apply not S21 in no one not one S21 and R2. So now we will apply modus ponens to not S21 and R2, which is actually a not S21 implies not W21 and not W22 and not W31, which will gives an output as not W21 and not W22 and not W31. Okay, so this will be the output when we apply a modus ponens to not S21 and R2. Then again apply the elimination rule. Again apply the elimination rule. Okay. So now again apply and elimination rule to not W21 and not W22 and not W31. So we will get three statement, that is not W21, not W22 and not W31. Again apply modus ponens to S12 and R1. Okay. So apply modus ponens to S12 and R4, which is S12 implies W13 or W12 or W22 or W11. So we will get the output as W13 and W13 or W12 or W22 or W11. Okay, means this junction with the W13, W12 and W22 and W11. Here just check that here S12 when we apply S12 and R4, then here not are not written before the S12. So just check that. So that's why in the right hand side or means disjunction are used as a operator. So applying modus ponens to S12 and R4, we will get the result W13 or W12 or W22 or W13. Okay. So next is apply unit resolution. Next is apply unit resolution on W13 or W12 or W22 or W11 and not W11. Okay. So after applying unit resolution formula on this and not W11, we will get W13 or W12 or W22. Okay. Next, again we apply a unit resolution on W13 or W12 or W22 and not W22. Okay. When we apply this resolution on this, then definitely we will get W13 and W12, because see guys, um, when we apply end rule between these two, then what happened, W22 and not W22 will give you the false result, right? Will give you the false result, and when false is disjunct with the true value, then definitely that particular or make you can say that a false value is a disjunction with any particular value, then particular that value is actually as a result. So that's why W13 or W12 or false is given a result W13 or W12. Okay. Now again, now again apply unit resolution on W13 W13 or W12 and not W11. Okay. And not W11. So as an output, obviously W12 and not W12 will again give you a false result, but once it disjunct with the W13, then result will be given as a W13. So it is proof that W13 at a place W13 womb is present, right? So guys, see, guys, today we learn about the Wumpus World, right? So what is Wumpus World? As you know that it is mainly inspired by some video game. So definitely some graphical representation are also made for this. So that's why this made as a. So guys, see this in which 1 1 3 position Wumpus is present, and 2 3 position gold is present. Now at a 3 position pit is present. Okay. So pit is definitely whenever wherever the pit is present, adjacent room are written as a breezy. Okay. So guys, what happened, in which we assume that the square 1 1 it is safe. Okay. Because agent is reside at the first time agent is reside here, and it is safe. Okay. It assume that it is a safe. So now agent can move in a two direction, right? Either in so first of all, either in the right direction or at the top. So but in this example we are taking that it is actually facing at the uh, right side, right? So definitely it will first move to one direction, right? It will first move to one direction. Okay. So it have a two option, right? It have a two option. Either agent can go at a two one direction or one two direction. So definitely at first it goes to the two one direction. At first it goes to the. So let's understand. See, At first it goes to the 2 1 direction, because see, uh, at 1 1 position it doesn't it have only two adjacent, that is 1 2 and 2 1. So right now, it found that the 1 2 and 2 1 both are okay, so that's why it's written as a okay. Okay, and now it's moved to the first 2 1 direction, and when it reached to the 2 1 direction it found that some breezy. So now point is, because it might be 2 2 and 3 1, um, either maybe both, and maybe any one of them contain a pit, right? So see guys, in the diagram, actually 3 1 at a pit. Okay, so that's why he doesn't know whether 3 1 contain the pit or 2 2 contain the pit. So it just mark as both as a pit. Okay, so maybe here maybe a pit, or here maybe a pit. Okay, so now it's again come back at the position 1 1, and mark 1 1 as a visited, and now it again reached to the 1 2. So once it reached to the 1 2, it checked that it find that some stench. So stench means definitely it's near some worms is present. So as 2 1 already visit 2 2, and it mark as a pit here. Okay, so guys, as we know, as you know that according to the rule, either any side pit is present. So definitely when it on the point 1 1 or 2, it have two adjacent, one maybe a means both wombs and pits both are not lies at the same time, right? So definitely it find that the position 1 3 it have a wombs, and this position that is 2 2 it is definitely okay. Okay, because it doesn't it can't go anywhere, so that's why it understand that, then definitely it will be okay. So now it's a mark as a okay at 2 2 position. Okay, now it's again reached to the 2 2 position. Now it have a two option, either either he can go in the right side, or right side, that is 3 2 position, or maybe 2 3 position. So for example, it goes to the 2 3 position, and once it reached to the 2 3 position, so it found the goal. So guys, it again come back and get a prize, that is plus 1,000 points. Okay, so guys, see, Wumpus World is actually mainly a game based solution, right? So before that, when we create a Wumpus World production rule or a knowledge base, before that uh, video game is actually launched. So on the basis of that, this knowledge base and all the things are made according to them. Okay, so today we will learn about the what is Wumpus World, uh, what are the PEAS description of the Wumpus World, that is performance, environment, actuator, and sensor. Okay, and how these actually works, how what are the performance measure, and what are the environments, and what are the actuator they what are the actuator we provide in this, and what are the sensors. Okay, sensor, what are the sensors present for the agent. Next we learn about the Wumpus world properties. What are the properties of the Wumpus world, that is partially observable, deterministic, sequential, static, and discrete, and one agent. Next we explore the how Wumpus world actually work. Okay, how Wumpus world actually work. After that, we learn how we represent the knowledge base, how we represent a knowledge base for Wumpus world. Okay, so there are some properties, some atomic proposition variable for the Wumpus world, and also some these are some rule propositional rule for the Wumpus world. Okay, for each row, that is R1, R2, R3, and R4. Okay, for each row, there are some properties are present. Um, some propositional rule, you can say that some propositional rules are present for this. Next is the representation of knowledge for a Wumpus world. How we represent actually a Wumpus world. So for each row, we found each and every variable value. Okay, for each row. For example, for row one, whether it is wombs are present at that position, whether it is stretch are present at that position, whether any pits are present, whether any breezy are present, whether any glitter are present, whether it is okay, whether it is visited. So obviously glitter, breezy, pits, and stretch and wumpus, these all are not present at the position 1 1. So that's why it's before that negation operator are written, and in a visited v11 and ok11 is written, because this position is okay and it is visited. Okay, that's why it is written. So this is a representation on knowledge base for the Wumpus world. Next, we prove that that the room 1 3 have a Wumpus, right? So by using a modest ponens rule, we actually finally we prove that yes, at the position 1 3, Wumpus is present. Okay. So now these are some homework for you guys. Just first learn this chapter properly, and do this homework. Okay. Okay, guys, this is an book which is written by the Rich and Knight. Guys, in the excuse me, in this book, there are so many other examples are also present. So you can learn from that, and also you can exercise and just find the solution for that exercise. Okay, thank you.